Alright, Part B, hose and flexible line used for the aircraft plumbing whenever the connecting of the components must be free to move whenever the extreme position vibrations are when the part deals with a different type of the hose within the use of Army aircraft, the materials for which they are manufactured, the method for the fabricating hose assembly. Also explain proper method for the hose installation for the requirements for the storing different types of hose for the hose assembly used with the conduct, air fluid with the engine oil, hydraulic fluid, water, anti-free, the hose pressure capability range with the vacuum, the found in some instrument lines that is several thousand psi found, some hydraulic system hose assembly out the never used in the aircraft oxygen system. Type of hose aircraft hose that composed of two or more layers of different material of the inner liner is leakage tight non-metallic tubing made with either synthetic rubber or Teflon liner reinforced against the swelling of the bursting of one or more outer layers braided into and encircle it. The kind of number of the layers of the braid depending on the intent of the operating of the pressure of the arranging for the hose of the assembly. Two materials used for the inner liner for the flexible hose with the synthetic rubber or Teflon. The two materials are used for the next paragraph discussed in paragraph that follows. Rubber hose, the inner liner of the rubber hose used in the aircraft plumbing system is made with the synthetic rubber. The various compounds of the rubbers are made with the inner liners. Each of the compounds provided for the hose with some special capability, such as usability for the certain fluid operable with a certain range of the temperature. The outer covering of the rubber hose is made with either fabric or rubber. The rubber hose is used in the aircraft plumbing of the system only with the form of the assembly. Assembly is formed with the attaching metal to the connection to each end of the section of the bulk of the hose. Teflon hose is the registered name of the tetrafluoroethanol, which is synthetic resin. Teflon hose is has a flexible leak-proof with the inner tube reinforced with the outside of one of the more layers of stainless steel braid. The Teflon liner is chemically inert with all fuel, oil, alcohol, water, acid, and gas. The liner can withstand the liner can withstand fluids temperatures ranging from negative 100 degrees Fahrenheit to plus 500 degrees Fahrenheit. The rubber hose and Teflon hose used for the aircraft plumbing system only is assembled. The pressure capability type of the material with the number of layers used in reinforcement braid determine the pressure range for the hose. The two pressure range for the classification of the air hose are medium pressure and high pressure. The medium pressure range includes operating pressures of up to 1500 psi or below, and high pressure is designated from operating pressure up to but not exceeding 3000 psi. Hose markings. Aircraft hose and hose assemblies can be readily identified. Markings found either stenciled along the length of the hose and printed within a fixed metal band. These markings indicate the date of the manufacturer, fabrication, size, the military specification number, the date of the pressure test, as illustrated in Figure 2.4. 2.4 shows the hosing markings. Marking in rubber hoses. But bulk rubber hoses are ink or paint markings on the outer cover. The identification of this information provided with these markings include identifying the name of the manufacturer, date made, the size, military specification number, the military specification number to provide the additional information reference with the specification table in Chapter 7 of TM 1 204 223.2. The information includes the hose pressure capability, temperature limitations. As the fluid of the liquids that can be used on some of the hose with the lace strip provided with the easy method to determine if they all installed with the hoses is twisted. Identified field fabricated the rubber hose with the assembly. The middle band is placed on around the hose. They identify the feeder federal national stock number of the assembly to give the operating pressure for the pressure date test. Marking on Teflon hoses. Bulk Teflon hoses identified with the brass bands with the space at 3-foot intervals marked within specification numbers, the manufacturing code numbers. The factory fabricated Teflon hose assemblies are identified with the permanent attached by metal bands marked on them with the military specification operating pressure for the PSI assembly part number, the date of the proof of test, the hose manufacturing code number, the local manufactured Teflon hose assembly identified by the aluminum band. The markings on the band can be impressioned, stamped, etched, or engraved and include the federal national stock number of the hose and part number, the manufactured part, and the depot code, operating pressure, and date of the pressure test. Hose size of the hose is expressed in the dash number as hoses of the size of the hose is expressed as a dash number. This refers to the inside diameter of the hose is expressed in the 16th of an inch. For example, -2 is 2/16 of an inch, -3 is 3/16 of an inch, -4 is 4/16 of an inch. Whenever the hose is in conjunction with the tubing, both of the hose of the tube must be equal size. And for example, the tube size of 1/4 inch of the out of diameter is a -4/16 of an inch hose must be used with it. Causes for a hose replacement. Replacement of the rubber hose assembly must be accomplished with the inspection intervals prescribed in the applicable aircraft maintenance manual, but the Teflon does not deteriorate as a result of the age. Therefore, the periodic replacement is not required. However, both the rubber and Teflon hose assembly subject to damage during the operational that can be caused the replacement of the line. Indicate that the replacement of the hose in the assembly may duplicate the original hose in length of the outside diameter, inside diameter contour, unless the line must be rerouted with the reason specified in paragraph, which discuss the routes of lining lines near the beginning of the lesson. 2000. Rubber hose, the evidence of deterioration of rubber hose assembly and urgent the cause of the replacement example of such deterioration, separation with the rubber cover, the braid, form of the linear cracks, hardening, the lack of the flexibility, the other type of the damage that cause of the replacement of the rubber hoses, cold flow, a deep penetration and pressure crack produced by pressure of the hose lamp, weather crack, the weather damage that is deep or wide enough to expose the fabric, broken wires, 2 or more broken wires per plate, 6 or more broken wires per plier foot, or any broken wire in position where kinking is suspected for pressure for the 500 psi and over. Teflon hoses. Installed Teflon hoses assembly must be inspected for evidence of deterioration due to the wire and fatigue chafing at the periods prescribed by the applicable aircraft inspection maintenance manual. The replacement of these lines must be made with the following conditions are found: leaking static leaks exceeding with one of the drop per hour, the excessive wire damage to 2 or more broken wires in single plate, more 6 wire per linear foot, or any broken wire any position where the kink is suspected, distortion, any evidence of abrasion, kinking, bulging, or sharp bending. Fabrication of hosing assembly. Hose assembly, for the most part, are available through supply channel to the factory. The prefabricated parts for expeditionary field expeditionary when they require assembly are not available. They can be fabricated in accordance with the following specifications and procedure. Fabrication medium pressure rubber hose assembly. Medium and pressure rubber hose assembly are fabricated with the bulk hose conforming to the military specification MIL H8794. The fittings conform with the military standard MS28740. Part of the assembly processing before cutting, visually check for the bulk of the hose with any mutilation, mark seams, excessive graphite. Check the fittings of the mutilations for threaded areas and nicks. Distortion, cracks, and any other damage that can cone seat the ceiling surface to finish that they can affect with the corrosion of the resistance of the fitting. After the hose and the fittings have been inspected, determine the correct length of the hose required as shown in figure 215. Cut the hose squarely using a fine tooth hacksaw, then using a compressed air cleaner to the hose to remove all the cutting residue. Caution: do not intermix the socket and the nipple from one manufacturer with those of another. All fittings are marked with the manufacturer's symbol. Figure 215 shows the determination of correcting of the hose, length of the hose, and length of the assembly. Symbol of the hose fitting is illustrated in figure 216 with outline for the following steps. Place cycle the device with the screw of the hose in the socket counterclockwise until the top bottom of the valve with the back off the hose, the 1/4 inch, 1/4 of the turn. Caution: do not over tighten the device on the thin walled sockets with the light white fittings. The tightening of the nipple, the nut for the appropriate assembly tool for Aero Equip kit and part number S1051. Lubricate the nipple threads for the inside of the hose. Liberally use a lightweight motor oil or hydraulic fluid, MIL H5605 or MIL H83282. Screw the nipple into the socket hose using the wrench of the end, and on the nipple a hex nut with the nut must be swivel freely when the assembled tool is removed, and after the fabrication process is completed, inspect the assembly external for the cousin bolts for the inner liner. The final steps of any hose fabrication process is to prove test the hose assembly to ensure the pressure compatibility. The step is discussed in paragraph on testing hose assemblies. Fabricating high-pressure rubber hose with assembly. High-pressure rubber hose assembly MS28759, MS28762. Fabricated high-pressure bulk hose conforming to the military specification MIL H8788, MIL H8790. Fitting conforming to the military standards MS28760, 28761. Fabrication techniques and tools. Assembling the high-pressure hose are the same as those outlined medium-pressure fabrication. Caution: not you reuse the high-pressure hose. The high-pressure hose fittings also never reinstall the fitting on the same area of the hose whether it was first installed, if any of the error, where it was first installed, if any error was made during assembly, cut away the old area, use a new fitting of the length of the hose, and reinstall the fitting. Alright, fabricating medium pressure Teflon hose assembly. Medium pressure Teflon hose assembly manufactured with the requirements military specification MIL H255779 for the bulk hose conforming to the military specification MIL H27267, ending fittings conform with the military specification MF27272. All fabricated Teflon assemblies must be identified by aluminum alloy tags NSN 95350023276. 600. Composition dimension of these tags are found on the Chapter 4 Technical Manual 15115220423. The tags are marked to show that the Federal National Stock Number, Part Number, Depot Unit Code, operating the pressure and date of the pressure test. The step to be allowed fabricating with those hoses assembled described in Technical Manual 115002042. Fabricating high-pressure Teflon hoses assembly. High-pressure Teflon hoses assembly are manufactured with a bulk hose conforming with the MIL H83298 and end fittings conforming with the MIL H83296. Alright, and then there's a 216 is assembly of a hose and fittings. Testing hose assemblies. Prior to installation, all fabricated hose assemblies must be pressure tested with applies regardless of whether they were just fabricated with the previous fabricated test and placed in storage. All factory depot fabricated assemblies must be pressure tested prior to installation. Home assembly with the use of the hydraulic, pneumatic, fuel, oil, coolant systems are tested on the hydraulic tested unit filled hydraulic fluid conforming with the military specification MIL H5606 and MIL H 83282, MIL H6083, lubricating oil conforming with the military specification MIL H6082, or water hose assembly to be used in the instrument system and the tested with using dry, oil-free, oil-free or nitrogen federal specification 1313N411. Grade A Type 1 steps involved with the testing process are explained in detail in Technical Manual TM 1-1500-204-23-2. Installing hose assembly. During operation of the hose assembly, change the length of the plus 2% or -4% with the pressure of the pressurization. Compensate for the slack equal to at least the 5% of the hose length must be allowed to expansion for the shrinkage. 5% allowance must be provided with the cutting of the fabrication. In addition with those hose, care must be taken not to twist the hose. Exceed the allowed bending radius. Support with the grommets must be used and fittings lubricated with the protection against the temperature provided with each of these discussed in the paragraph that followed in illustration figure 217. Most of the hose is marked with a lengthwise solid line with the lay of the strip, either detecting any twist in the line during the installation. Twisted hose tends to untwist when the pressure is causing the end fitting becomes loosened and shear, but to avoid twisting head hose assemblies when connection of the second end of the use of two wrenches for using the two holes the stationary fitting of the one-turn swivel nut. Bending radius. Hose-like rigid tubing that has a limited bend allowance. Bending exceeding the permissible limit leading to early failure to hose with the bending of the radius. Sharpens the bending permissible for the hose to refer to the minimum bending radius for that hose. The bending radius is measured with the same manner if the bending of the minimum bending radius for the rigiding tube is described in paragraph of this lesson entitled Routing Lines. Supporting and grommets. Teflon hoses require that different kinds of support that use the rubber hose. However, the following principles using support and applied to both rubber and Teflon hoses. Hoses must be supported along its length with the intervals of 24 inches or less. Depending on the size of the hose, these supports shown in the figure 218 must be installed with such a manner that they do not cause deflection of any rigid lines where they are connected. When a hose is connected with the engine by a hose clamp, the support must be replaced approximately 3 inches from the connection. Add at least 1.5 inches of hose with the slack provided with the connection with the engine to keep the vibration and the torsion from the damage of the connections. When a hose passes through the bulkhead of the grommet, must be installed with the bulkhead of the head hole to provide with the support with the housing to prevent the shafting, and the alternative of the cushion clamp that can be used on the hole. The hole is large enough to provide adequate clearance around the hose. The hose assembly connecting the two rigidly mounting fittings must be supported firmly but not rigidly. Lubricating. The swivel parts mating with the surface of the hose assembly must be lubricated before installation. This ensures the effective seating and tightening of the components parts with oil, water that can be used in all types of fuel, oil, and oil coolant hoses when installation is made, except for the self-sealing hoses, which must never be lubricated during installation. However, the only oil or other operational fluid of the system must be used on the hydraulic or pneumatic hose. Alright, 217 shows the connecting of hose lines, right and wrong. Figure 218 shows hose support. Support for the temperature protection. How a hose must be protected with high temperatures such as exhaust blast or hot engine parts. In this area, the hose must either be shielded or relocated to shield for the temperature protection is shown in Figure 219. Temperature protection. Right and wrong. Alright, storage. Proper storage handling of the aircraft hose to the hose assembly with the responsibility of all activities engaged with the aircraft. Maintenance of the aircraft hose. Associated rubber components must be stored in the dark, cool, dry places protected with exposure to the strong air currents and dirt. Stored rubber hose seals must be protected with either electric motors or other equipment emitting the heat or ozone hose. The components must be stored in the original packing issued. The oldest item are issued first. Neither Teflon nor rubber hose has limited shelf life. However, the prior installation of all hoses in the assembly must be inspected to ensure the serviceability testing according to the procedure listed in paragraph testing of the hose assembly. Bulk hoses. Prior to being placed in storage, the end of the hose must be capped to prevent flare out the dirt and contamination. Storage the straight position is preferred manual. However, if the cooling necessary, large loose coils must be made. The hose assembly. The end of all the hose assemblies must be capped during the storage of the polyurethane protected plugs in conforming with the National Aerospace Standards 815 and equivalent to prevent contamination. Caution: under no circumstances must a hose be piled to a height that can result in damage to the under section. This caution applies to the hose and cartons as well as the unpacked hoses. Summary: hose in the aircraft plumbing. Whenever the connected with the components must be free to move whenever the extreme vibrations are a problem. The aircraft hose is composed of two or more layers of different materials. The inner layer of the liner is sleek, tight, non-metallic tube made of either synthetic rubber or Teflon. The liner reinforced against the swelling of the bursting of one or more outer two layers. Braid. The kind of number of the braid layers depend on the intent of the operating pressure range of the hose assembly. Pressure capability of the hose assembly is divided into two general categories: medium and high pressure. The medium pressure ranges include operating at a pressure of 1500 psi, and below high pressure hoses are designated for operating pressures up to but not exceeding 3000 psi. Aircraft hoses and hose assemblies can be readily identified markings either by stencil along the length of the hose with the imprinted on the affixed metal band, but these markings include the date of the manufacturer, fabrication size, military specification number, date of the pressure test, hose size expressed in 16th of an inch by a dash number referring to the inside diameter of the hose. The replacement of the rubber hose assembly must be accomplished at the inspection intervals prescribed in the applicable aircraft maintenance manual. The Teflon hose does not deteriorate as a result of the age, therefore periodic replacement is not required. Both rubber Teflon hoses assemblies are subject to damage during operation. They can cause for replacement. Example of these damages are cold flow, weather checking, leaks, and broken wires exceeding limitations. For the most part, hose assemblies are available through the supply channels and factory prefabricated parts for expeditions. However, they are field fabricated in accordance with the outline specifications. High pressure Teflon hose is available to prefabricated assemblies only. Field fabrication is not authorized prior to installation. All field fabricated hoses assemblies must be pressure tested, fabricated or factory or depot lubricated. Assemblies must be pressure tested regardless of whether they were tested at the time of the manufacturer. During installation, care must be taken to ensure the line is not twisted, bent, and is not exceeding the limits. It must be support along with the length of the intervals of 24 inches or less, depending on the size of the hose. Swiveling parts and mating surface of the hose assembly must be lubricated before installing to ensure the effective seating of the component parts. Self-sealing hoses must never be lubricated. Aircraft hoses, rubber components must be stored in dark, cool, dry places protected with exposure to strong air currents and dirt. Neither Teflon nor rubber hoses is limited in this shelf life. However, prior to installation, all hoses and assemblies seals must be inspected to ensure serviceability. Part C, seals and gaskets. Alright, we're gonna close that.